finding the stationary points on a curve means finding those points where dy by dx is equal to 0. And determining their nature means telling whether they're a local maximum or a local minimum. So we're going to have to differentiate. So we want to find whether dy by dx, what value of x will make dy by dx equals to 0. So let's find dy by dx, or what I'm going to call f dash. So our first derivative, it looks like we have a product. So we're going to treat this as a product and apply the product rule. So it'll be the derivative of the first multiplied by the second, u dash v, plus u, that's x, multiplied by v dash, which is e to the minus x squared. The derivative of an exponential is unchanged, but because we have x rather than x squared, we apply the chain rule and multiply by the derivative of the power, and that gives you minus 2x. So my final value for the derivative, my final expression, will be e to the minus x squared minus, because you're multiplying by minus, so that'll change that sign, minus, and I'll multiply the x times the x, so I'll get minus 2x squared e to the minus x squared. So that's my dy by dx. That's my expression for the first derivative. But really, they're not asking for that. They're asking for the stationary points. That means the points, the values of x that make that derivative equal to 0. So we're going to be solving f dash equals to 0. Now, how do you do that? This is such a strange expression. So, looking carefully, it looks like this exponential appears twice. So, it looks like it's a common factor that I can factor out. So I'm going to take e to the minus x squared as a common factor, and that makes my expression much nicer once I've factorized it. And we like it when we factorize expressions and make them equal to 0, because it means that one of these, at least, has to be equal to 0 for the result to be 0. So I can say either this equals to 0 or that equals to 0. So either e to the minus x squared equals 0, or 1 minus 2x squared equals 0. So either of these will give me my stationary point. Now if you look at this, that's an exponential, and an exponential can never be 0. You can't raise a constant number to any power to give you 0. So e to the minus x squared will give you something like this. And it will approach 0, but it'll never give you 0. It's not possible to find a solution for this. So we can just reject that. This is not possible. So there's no solution for that. There's no value of x that will make e to the negative x squared 0. So no solution. This, on the other hand, looks like it does have a solution. So we can say 2x squared equals 1. X squared is 1 over 2. And x would be either positive or negative 1 over square root of 2, which you should probably write as square root of 2 over 2. But basically the square root of half. And we say positive or negative, so there are two possible values. So when there are two possible values, you need to find the corresponding, well, even if there was one possible value, you need to find the corresponding value for y. So I'm going to say if x1 is root 2 over 2, then y1 equals, and we simply apply the formula. So this is the expression we have for f of x. I'll just write it as f of x1 and you simply substitute. So it'll be root 2 over 2 times e to the minus half. So that's your first stationary point. Your second stationary point will be the same, but with a negative value. So I'll just copy that out. So we'll just put a negative sign here and a negative sign there. So I've changed that and that, but it won't change this because it's squared. So these are our two stationary points. So x1, x2. But the question said, find the stationary points and determine their nature. So we need to determine whether they're local maxima or local minima. And to do that, we need the second derivative. So just as a reminder, what we do is we find the second derivative of x1 and we say if, or second derivative, let's just say in general, of x, we're going to say if the second derivative is positive, then we have a local minimum. And if the second derivative is negative, we have a local maximum. Now, if it happens to be 0, then it's neither a minimum nor a maximum. It could be a point of inflection. So let's find the second derivative. We'll start from the first derivative. So this is f dash. Let's differentiate that to find the second derivative. So what we want is to find the second derivative. So here we have two terms. The second term looks like it's a product. So here we're going to have to use the product rule. Again. So the derivative of an exponential is an exponential, but we're going to have to apply the chain rule. So it's going to be e to the minus x squared multiplied by minus 2x minus, that's that minus, and now we're going to have to use brackets because the chain rule, sorry, the product rule will have a plus in it. So I need to make sure this minus sign doesn't get lost. Right, so it's u dash, if this is my u, the derivative of 2x squared is 4x multiplied by v, unchanged, e to the minus x squared plus 2x squared multiplied by the derivative of this, which we keep doing. I'll just write it as minus 2x e to the minus x squared. Let's try to make some space. Okay, so I can close these brackets and then these brackets. So I didn't include the negative sign in my u, So I've treated u as if it were positive, and I kept this minus sign outside. You might choose to use the negative as part of your u, and then you wouldn't need these brackets. Okay, so I can then multiply by the negative, and I'll simplify this. So let me rewrite it a little bit more neatly. My second derivative, f double dash. I'll bring this here, so it's minus 2x e minus x squared minus 4x e to the minus x squared minus 4x squared. So I multiplied the 2 times minus 2. That gave me minus 4. But then I need to multiply by that minus. That will give me plus 4. And then I multiply by e to the minus x squared. And finally, I think it makes sense if I were to take e to the minus x squared common, because there's such a lot going on. And if I do that, it looks like these two become like terms. It's minus 6x. So I can say that this is e to the minus x squared brackets 4x squared minus 6x. So that now looks like I could use it to find the nature of my stationary points. How do I find the nature? Well, I need to substitute the values of x1 and x2 and determine whether the second derivative is positive or negative. So let's look at f of x1. So that's f of 1 over square root of 2. So that's going to be e to the minus 1 over 2, which is positive, times 4 times 1 over 2, which is 2, minus 6, 1 over root 2. And if you put that in your calculator, you're going to get a negative answer. And that's what matters, because if the answer is negative, you can say that the stationary point at x1 equals 1 over root 2 is a local maximum. That's what matters. They're asking us to determine the nature of the stationary point, and we've determined the nature by saying it's a maximum because the second derivative at that point is negative. Now we can do the same for x2 exactly the same way, but this time x2 is negative 1 over root 2, so that's negative, so we now have a positive here. And if you put that in your calculator, you're going to get a positive number. And because it's a positive, then the stationary point at that point, minus 1 over root 2, is a minimum. Okay, so it's important to realize that it's the second derivative you're looking for. You don't set it to 0. What you do is you substitute the value that you found initially when you said that the first derivative was 0. So when we worked here, we found our solutions for x. It's these values that you need to substitute into the second derivative to see whether the answer is positive or negative. And if the second derivative is negative, then that point was a maximum. And if the second derivative was positive, then we have a minimum. So that's how you deal with questions that ask you to find the stationary points and then determine their nature.